Let us do this activity. Take a piece of stone and tie it to one end of a rubber string. Measure the length of a rubber string before suspending. Note that it is equal to 50 centimeters. Now suspend the stone by holding the string as shown. The string gets elongated. Measure its length in this state. It is 55 centimeters. Now slowly dip the stone in the water in a container as shown in the second case. Observe what happens to elongation of the string. Measure the length of the string in this state too. You will find that the elongation of the string decreases as the stone is gradually dipped in the water. Now measure the length of the string. It is 53 centimeters. But there is no further change once the stone gets fully immersed in the water. The explanation of this is given by the Archimedes Principle. The elongation is produced in the string due to weight of the stone. The extension decreases when the stone is lowered in water. It means that some force acts on the stone in an upward direction. This is the buoyant force acting on the body. The magnitude of this buoyant force can be determined by Archimedes' Principle. Archimedes' Principle Statement: when a body is immersed completely or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. About Archimedes. Archimedes was a great Greek scientist. He was assigned a job by the king to verify the purity of the gold used in the crown. He discovered the Archimedes Principle after noticing that the water in a bathtub overflowed when he stepped into it. He ran through the streets shouting, "Eureka!" means "I have got it." Using this principle, he determined the purity of the gold in the crown. His work in the field of geometry and mechanics made him famous. His understanding of levers, pulleys, wheels, and axle helped the Greek army in the war with the Roman army. Application of Archimedes' Principle. 1. It is very useful in designing ships and submarines. Submarine is a ship which can float on the surface of the sea or can sink when necessary and reappear again on the surface. It is provided with large tanks both at the front and at the back. These tanks can be filled with seawater or air from compressed air reservoirs. If the tanks are filled with water, the weight of the ship increases and hence it sinks according to the requirement. Hence, the buoyancy force exerted on the submarine is less than the weight of the submarine. If water from tank is pumped out by forcing compressed air in them, now the ship becomes lighter and rises to the surface because the buoyant force in this case is more than the weight of the submarine. The submarine is such designed that the weight of the water is displaced by the submarine when filled with air is more than the weight of the submarine. 2. Various instruments like lactometer, hydrometer are based on this principle. Lactometer is a device used to determine the purity of sample of milk, while hydrometer is used to determine density of the liquid. The depth to which these instruments dip in the fluid depends on the density of the fluid.